It's really easy to convert text into audio files. I want to use OpenAI's API to do it, and I want to implement that using the Spring framework. Welcome to Tales from the Jar Side. This is the documentation page at platform.openai.com, centering on the part that talks about text-to-speech, learn how to turn text into lifelike spoken audio. So they have a whole discussion here about the speech endpoint, which looks like this. So you send a post request to this URL, and this is documenting what the post request looks like. We'll take a look at that in code. And also the text-to-speech model. Now, there are two models available for this, TTS1 and TTS1 HD. They really don't sound all that different, but we'll try them both out here. Going back to the endpoint, we see that what we're going to do is send a post request to this URL, and we have to supply the text. Now, we pick which model we're going to use, TTS1 or TTS1 HD. The input string is the text we want to generate audio for, and then we pick a voice, and there are 6 available voices. We can't change the voices, we can't tune them in any way, but they're all immediately available, and we'll take a look at that. The response format describes what we're getting back, and the default is MP3, and that's fine for what we're going to do. And then there's an optional speed value, which ranges between 0.25 and 4, and all of those numbers will be used in order to create the audio file that we need. Now, this is a Spring Boot application, and it's using the very latest version of Spring Boot. At the time of recording, that's 3.2.1, I believe. What I've done to start the application is to create a record, a Java record, that maps to that request that we saw in the documentation. So we need a model and an input, those are both strings, and then a voice and a response format and a speed. Of those 5, the only ones that are required are the model, the input, and the voice. So while I put all 5 of those in the constructor, I've added a second constructor that delegates to that first one and uses as a default the response format of MP3 and the speed of 1.0. We've also made both the voice and the response format into Java enums. So let's take a look at those. First of all, the voice here is an enum with all the capital letters typical of Java records showing the various options. And the JSON property annotation allows us to use them in lowercase when we create a JSON version of the voice. But those are the 6 available voices inside the API. Likewise, the response format is also an enum, and we're going to stick pretty much with MP3, but you see again, the only interesting fact here is we're using the JSON property to make sure we get lowercase in our JSON data instead of the constants as we see them there. And now comes the fun part. One of the things that was added to Spring Boot 3, or more properly, Spring 6, was this idea of using HTTP exchange interfaces. This one right here is an interface that I called TTS interface, TTS for text-to-speech, and you see it has one abstract method in it, get text-to-speech response. It takes one of those TTS requests in the body, that's what the request body annotation is for, and it returns a byte array. Now, the annotation on it is post exchange that says we're going to the audio/speech endpoint that comes after the V1 that's up at the top in the HTTP exchange annotation. We are going to be sending JSON data. That's what the content type property is saying. And we're going to get back audio/MPEG files. So we're specifying the MIME types of what we're sending and what we're receiving, and we annotate this with post exchange, and then Spring will automatically create a class to send a post request with the body that we supply and getting back the byte array. Now that actually would be enough to get started, but in general, I usually like to have some pre-processing before I make the request and some post-processing afterwards. And therefore, in this case, I'm looking at a TTS service. So this is a service class inside of Spring. I've got a logger there. I have constants for both the model types. And you'll see that the TTS interface is auto-wired into this class. I auto-wired it through the constructor. So the first method we see here, called getAudioResponse, takes a TTS request and logs it at debug level, and then invokes the getText-to-speech method or getText-to-speech response method on the interface, getting back the byte array. But here's what I mean by post-processing. I want to write that byte array to a file. So I have a special file that's not shown here, a special method to write the sound bytes to the file. It's in the GitHub repository, which returns an auto-generated file name. Then I'm going to log the file name, and we'll see that and return the bytes. Now, the other things I have in this class are some overloads of the same method that allow me to supply, for example, the model, the text, and the voice, and then create the TTS request and call the main method, or just the text with a couple defaults, or the text and the voice, or the model and the voice, and all of those will work just as we're saying. In order to make the HTTP Exchange interfaces work properly, you have to configure a bean. Now, most of that configuration is boilerplate, but here I've separated it into two beans. Now, I'm using the so-called Java config approach inside of Spring. I have a class that's annotated with that configuration, and inside here I have two methods annotated with that bean. The first one is to create the REST client that I'm going to need to do the networking. The @value annotation is used to plug in the base URL to get to OpenAI, as well as my OpenAI API key, which is currently an environment variable. You could see the way to create that bean is just to invoke a builder, pass in the default header being the authorization header with the API key plugged in as required, set the base URL and build it. And then the second bean, this is the boilerplate one. You pretty much get this right out of the documentation. You plug in the REST client, get back the TTS interface itself. So all you do is call create on the REST client adapter, and then use this little boilerplate to make an HTTP service proxy factory, and then create a client from it, and you're done. And it wouldn't matter how many other endpoints I accessed at the same base URL, whether they were get, post, put, or delete. This is all I would have to do to set up the relevant beans. So this is one step, and it happens very easily, and it's a lot of it is just boilerplate. Now we can go on and use it. We certainly have enough now for a test. So this test of the service is a Spring Boot test that auto wires in our service. And then the test calls the getAudioResponse method and instantiates the TTS service in the method by supplying the model and the text in the form of a Java text block. And then we picked one of the voices, and we just assert that the audio coming back is not null and has a length greater than 0. Of course, that's going to be saved to a file, and then we can go ahead and play that file. Let me exercise this service, this test. Let me run the test so you can see the process.
The YouTube channel, Tales from the Jar Side, is your best source for learning about Java, Spring, and other open source technologies, especially when combined with AI tools. The companion newsletter of the same name is also a lot of fun.
Now, actually, that process would be enough. I mean, we wound up generating an audio file just the way we expected to, but we can do more. So here we're seeing the Gradle build file, and you see that I've added an additional starter, the validation starter. This is an implementation of a validation mechanism that follows the Bean validation spec. With that, I can now modify my request and use the various annotations from Jakarta Validation Constraints package. And you see, for example, I could say the model has to have the pattern of TTS1 with or without a -HD, with or without the date timestamp on there. The input can't be blank, but its max size, according to the documentation, is only 4,096 characters. The voice and the response format are already enum, so I don't have to do anything special with those. And the speed has a decimal min value of 0.25 and a decimal max value of 4.0. With these annotations in here, now I can go back to my text-to-speech service, and I can auto-wire in a Jakarta.validation validator. That's an interface, but the Hibernate validator will be auto-wired in automatically. Then all I have to do is validate it. So I put in a simple method here to invoke the validate method on the request, which will give me a set of constraint violations. And if that is not empty, then I will throw an exception and point that out. But that's how easy it was to add validation to this, because Spring Boot makes it very simple to add in the bean validation spec right inside there. Now, the next step is I would like to actually play those MP3 files inside my Java system. That requires an API for that. And the one that I've settled on is this old project called JLayer. And JLayer has been around for many, many years, as you can see here. But it turns out that all you have to do is add a repository to your Gradle build or your Maven build file, and then add the dependency in Gradle as well, and then instantiate it inside your system. So let's take a look at that. So taking a look at the Gradle build file, you can see in the repositories block, I've added that Maven URL for jitpack.io, and I've also added as an implementation scope that JLayer dependency with the given artifact ID, name, and version number. That's all I needed to add there. Once the project is resynchronized, now I can go back to my service, and I have methods like this, create and play, which will go ahead and create the request and get back the response. And this time I'm going to play it. So playing the byte array simply means that I instantiate a player that's down here. The player class implements a simple player for the playback of the MPEG audio stream, and that takes as an argument in the constructor an input stream. So in this particular one, I'm wrapping that in a byte array input stream to turn into a buffered input stream so I could play it here. And this way I could, all in one test, run everything. We'll take a look at that next. So here's a test to do everything, and this one is going to select a voice at random. I added a trivial little method inside the voice enum to pick one of the voices at random. I'll print out which one I'm using, and the text is one that has a series of technical words in it as well. The only quirk I had to do is I had to put a dash in the word JUnit in order for it to pronounce that correctly. But let me run this test and you'll see what we get.
This application uses Spring Boot's HTTP exchange interfaces as well as Java records, text blocks, enums, and the var reserved type name to access the OpenAI API web service. The embedded JSON parser is Jackson, customized to use Java records instead of POJOs, and the enums are translated to lowercase using the @JSON value annotation. Testing is done with JUnit 5 and the AssertJ testing library. Since the cost of the base TTS model is only 1.5 cents per 1,000 characters, this test costs less than a penny to run.
Now let's add in one last really cool feature. Since this is truly a stateless service, anything we need we're supplying every time we make a request, this is a natural for the so-called function as a service mechanism. That means it makes sense for me to add the GraalVM native image build tool inside here in order to run that as an executable with no startup time. So you see here I've added the Graal plugin, and that means that in my Gradle build file, I can now generate a native image. What I had to do is I had to switch and make sure that I'm running the Graal virtual machine, or I could have used Docker. But in this particular case, I did in fact use the Graal virtual machine. What I did is I actually executed the native build command, and it took a few minutes, maybe a little bit less than that, to generate the executable. The executable here is called OpenAI client in this particular case, and it's underneath the build native compile directory. In order to start it up though, watch how fast it starts up. Bang, it's already running. So it started up in a little bit less than, well, a little bit more than 0.6 of a second. And I've had some variation on that. Sometimes it's half a second, sometimes it's a little more. What I have here is the built-in HTTP client inside of IntelliJ as a way of executing it, as a way of accessing it. So why don't I execute the post request to that endpoint, and supply the text as part of the test here. Let me run it. And you see that the response was output immediately. And it already tells me the content type is right. I got back a 200. And if I look in the console here, you will see that this is the new audio file that has been created. And now I'm all set again. Pretty impressive. So you see, just to give you a review of the steps we went through, in this particular RESTful web service, all I needed to do was to map the input JSON request, and it only had 5 possible properties in there, and only 3 of them were required. So I mapped that to a Java record. I wound up adding some validation mechanisms on there as well, even though that wasn't really necessary, but it was a good thing to do. I used Spring's HTTP exchange interfaces to make it easy to create that. And then we configured a bean in order to access the RESTful web service. The interface was auto-wired into a service, which allowed us to pre-process and post the request and post-process the byte array that came back so that I could save it into a file or play it into some player. And then we just went through and executed it. And to cap it all off, we turned the whole thing into a native executable using the Graal native image generation tool. Everything done with Spring. I hope you found that really helpful. And if you want more information on how to work with Spring or how to access many different other types of AI endpoints and other platforms, as well as Claude and many other possibilities, I have a whole playlist on that on the Tales from the Jar Side YouTube channel. So we'll talk about that in the next one. Thanks a lot.
Hey there, Des, it's time to tune in to Tales from the Jar, so let's begin. Java, Kotlin, and Spring, oh my. Groovy, Gradle, don't be shy. Tales from the Jar side, oh yeah. Crack open the code, let's take a ride. From design patterns to the latest trends, your weekly tech talks that never end.